Aluminum silicon combinations, we tweak thermal expansion, stiffness, vibration damping, and density. And that makes it attractive for the entire precision equipment world.
Hi, Roger. How are you?
Hi, how are you doing?
I'm Slavik. I'm a technical solution engineer at Machinix. And you're from RSP Technology.
RSP Technology, Roger Sanden, and I'm taking care of product development and market development. We as RSP develop and produce aluminum-based alloys.
Yeah.
And we use a melt spinning, a certain technique to produce the materials, which is called melt spinning. And what we try to realize is to quench the material from melt to solid as quick as possible and freezing the liquid. One of our most dominant product families are aluminum silicon combinations. And with aluminum silicon combinations, we tweak thermal expansion, stiffness, vibration damping, and density. And that makes it attractive for the entire precision equipment world.
Right, right. And we are working with semiconductor industry, okay? And this is how we met actually. So maybe you can tell a little bit about how these kind of materials can benefit the semiconductor field.
A variety of applications, such as fast-moving parts for vibration and stiffness, frames for thermal stability, and manipulating temperature if necessary. Fast-moving parts in production and accuracy in metrology. And someone needs to produce the material, transform the material into a part, into a physical part.
Absolutely, and this is where we come in. We have been machining RSA 443.
Yes.
And we have, I would say, good experience with this material. We produce many kinds of parts, mostly machined like 5-axis milling parts, but also the turning and both milling and turning on the very complicated parts with very high-end tolerances, like less than 10 micron. And it's been a little bit challenging at the beginning, but we've had your support, your technical support and availability, and I really appreciate it. And
nice to hear.
and now when we've reached a stage where we're going into production quantities and not just prototyping, we found challenges with the kind of toolware that we're getting. And maybe you can tell me what could possibly solve that from your experience.
Yeah, so if the setup for manufacturing and the tool setup is correct, what we experience is that toolware is a little bit higher, not super extensive. You can use conventional kind of setups, you can use conventional kind of feeds and speeds, but you need to tweak things in the detail. And in terms of machining speeds in general, our experience is that you are, let's say, 30%, 25% slower.
But wait, where is it coming from? The wear itself. It's coming from the 40% silicon
yes,
that is inside, that is part of the composition of the RSA 443.
Yes, if you want to compare, let's say, to visualize what's going on in the material, you can consider a piece of butter with sand grains inside. And the butter is not so much a problem, but the grains are a problem. The bigger the grains, as in a conventional material, they eat your tool very quickly. The smaller the grains, the easier the machining goes.
Okay.
So that's part of the deal for us, to keep the cooling speed, the quenching rate as high as possible, and the silicon particles as small as possible.
So what is the quenching rate? I saw in your website it's about like 1 million degrees Celsius or something like that?
Yes, the cooling rates vary in the range 1 to 10 million degrees per second.
That's amazing.
It's difficult to clock it with your stopwatch.
I don't know how you control this process. It sounds so complicated. I'm really happy to see you at this Photonics West 2024 in San Francisco. It's been this is our last day here, and I hope we get to meet many more potential customers, me and you, together, and continue to collaborate. It's really nice to meet you.
That sounds like a plan.
Yeah.